Hey guys, welcome back to another relative velocity example number 5 for two-dimensional kinematics. For part A, at what upstream angle must the swimmer in video 51 aim if she is to arrive at a point directly across the stream? And B, how long would it take her? So this video is connected to the previous one, number 51, so I'm just going to put that back up on the screen for a moment. So in video 51, this was example 4 for relative velocity. We had a swimmer swimming at 0.54 meters per second in still water. The river was 77 meters wide. The current in the river was moving at 0.45 meters per second. And this is what we were dealing with. Okay, so we had the swimmer trying to go across. We had the water pushing her down, and so the net direction she was moving was slightly to the right of where she was moving originally. Now, for this example, we're trying to find out how to do it so that this resultant velocity, how her resultant velocity relative to the land is actually straight. So she actually ends up going straight across. And in order to do that, she will need to swim against the current. So she's going to swim against the current. The current's going to bring her back, and the relative resultant motion will be straight up. Okay, so here is what we're dealing with in this problem. So we've got our river, just like in the previous video, it's 77 meters wide. Okay? And what we know is that the velocity of the water relative to the land is moving towards the right. We know that we want her to be going straight up as the resultant. So we want this to be our VSL. And in order to do that, she's going to have to swim upstream. Okay, so that's going to be our V swimmer relative to the water. And these two meet at right angles. So your resultant is actually moving straight up. Okay, and the angle then we're going to be looking for is this one right here, which is theta. So if we take this diagram and we form it into a simple triangle, what we've got here is a right angle problem like this. Okay, where this side of the triangle, this is the water relative to the land. The water is moving at 0.45 meters per second. Okay, the swimmer can swim at 0.54 meters per second, and we're trying to find out this unknown side and this angle. Okay, now, as usual, we're going to define our positive direction. So up and to the right, right will be positive, x, up will be positive y, and it's a simple trig problem at this point. Compared to this angle, we know the opposite side and we know the hypotenuse. So we are dealing with sine. Okay, so if we do sine of theta is equal to opposite over hypotenuse, which in this case is 0.45 meters per second over 0.54 meters per second, then we're going to take the inverse sine of both sides. So theta is equal to the inverse sine, and of course 0.45 over 0.54 is going to be equal to, let me just grab a calculator here. So let's see, 0.45 divided by 0.54 equals 0.833. And when you take the inverse sine of that, you are going to get 56 degrees. Okay, so therefore, she has to angle herself upstream at 56 degrees. Okay, now 56 degrees is relative to the vertical, right? Now, we're going to be giving this angle relative to something that makes a bit more sense. Let's give it relative to the land. Okay, so let's actually give this relative to something called alpha. And alpha and theta are complementary angles. So alpha is in fact 90 minus theta, which is 90 minus 56. 90 minus 56, if you do that, you are going to get 34 degrees. So therefore, she must angle herself 34 degrees relative to the land. So there is your answer for part A. And for part B, how long is it going to take her? Well, let's look at it this way. Okay, so we know what angle she has to go at. In order to find the time, you have to know speed and you have to know distance. Okay, so let's take a look at it like this. In order for her to cross the river, she's doing this in a y direction. We have the displacement in the y direction. Okay, so we have to find the speed in the y direction. Okay, and in order to do that, well, the speed SL is equal to VSW times cosine theta. Okay, take a look at this original triangle we had. Okay, VSW is going to be the hypotenuse of this triangle. Okay, so the hypotenuse times the cosine of the angle gives you the adjacent, which is what we need, VSL. We actually are going to need VSL in the y direction, which is just VSL. The VSLY is equal to VSL, since they're both going in the same direction. So VSW is our 0.54 times cosine of, and this time we got to use 56 degrees since we're dealing with the original triangle, times cosine of 56. So VSL is equal to 0.302 meters per second, and that is the same as VSLY, because VSL is already going in the y direction. Okay, so let's move that up. So in order to find the time to cross the river, we're going to use our general kinematics formula, and that is that speed is equal to distance over time. We're going to specialize that for our case, and that is that VSL is equal to delta y over t. Y direction, componentless. T is componentless. Okay. We're going to now isolate this for time because we're trying to find how long it's going to take her. So time is equal to delta y over VSL. If you plug in your values, delta y is 77 meters. Our VSL is 0.302 meters per second. When you calculate that out, you're going to get t equals 255 seconds. Now, based on the original problem, we can only give our answer to two significant figures. So we're actually going to round this to 2.6 times 10 to the 2 seconds. Therefore, 2.6 times 10 to the 2 seconds is how long it's going to take her to arrive at a point directly across the stream. Okay, so guys, I hope that's making sense to you. I hope that's it. If you have any questions, be sure to check out video number 51, where I go through the majority of the problem, how to do it as if she has to actually end up a little bit downstream of where she starts. Okay? If you have any questions, be sure to drop a comment in the comment section below, and if you like the video, be sure to click that like button. Guys, I will be posting every day at 12 noon, so be sure to be on my channel at that time to check out my latest video. I will talk to you later, guys. Enjoy the rest of your day.